So here I'm going to discuss strong and weak acids and bases and how that differs from concentration. So the strength of an acid is determined by the extent to which it ionizes. So in every single definition of an acid or a base, we were ending up with some sort of charged particle, whether it was releasing hydrogen ions or forming hydronium ions. And so we can determine how strong an acid is by how well it does this. So how much it ionizes, or the percent of ionization. And this is different than the concentration of the acid. It's the concentration of its hydronium ions if we're talking about the Bronsted-Lowry definition of an acid and a base. So a strong acid is an acid that nearly completely dissociates, so completely ionizes. So all of the molecules that are added into the water of an acid break up to form ions. An acid that only slightly dissociates in the water would be considered a weak acid. So only a small amount of the molecules of the acid that you add into the water actually become ions. An example would be acetic acid. So if we look at a strong acid, it nearly essentially 100% ionizes. So hydrochloric acid is an example of one. So if we look here, you see hydrochloric acid plus water is going to make that hydronium ion and the chloride ion. So that's what we saw in the Bronsted-Lowry definition of it. So 100% ionization means that all of this has completely changed to this. So that's why we see the arrow in one direction. There are very few molecules and there are many ions. Now, a weak acid is one in which when we combine that acid with water, we form only few ions, where they're making few charged particles, and most of these molecules just sort of remain intact. So a weak acid does not dissociate and form as many ions in water. Now, because of the formation and the amount of ions that are formed, we can also relate the strength of the acid to how good they are at conducting electricity. So strong acids form a lot of ions, and therefore they're really good conductors or very strong electrolytes. Versus weak acids, they sort of stay in their natural form and they don't break down or dissociate into the ions quite as much, so they are considered weak electrolytes. Now, if we look at acids or bases, the strength of bases, it's very similar. So a base that dissociates completely into its ions is considered a strong base, and this includes all oxides and hydroxides of group 1 and 2, so like sodium hydroxide, magnesium hydroxide. These are considered strong bases. But a majority of bases are weak, so they dissociate only slightly in water, and an example would be ammonia. So if we look again, the reaction would be, or the chemical equation would be similar. So if we had a base and we put it with water, if we formed a lot of ions, and there was a lot of dissociation that happened, that would be considered a strong base, whereas weak bases, a lot of the molecules would remain, the water and the ammonia molecules would remain, and we have very few ions. So just like acids, if you are a strong base, you're going to be a strong electrolyte because of the amount of ions, and if you're a weak base, you're going to be a weak electrolyte. Now, we've talked in the first topic about concentration, and that was moles over liters. So I don't want you to get confused by talking about strength versus talking about concentration of acids and bases. So here is a 0.3 molar hydrochloric acid. This is a very dilute but strong acid. Hydrochloric acid is a strong acid because it dissociates into ions when it's in water almost 100%, but it's dilute because we have a small molarity per unit volume. Whereas if we have a more concentrated strong acid of like 2 molar or 12 molar, hydrochloric acid is a strong acid and the concentration is higher. Over here, we show an example of acetic acid, which is a very weak acid because it doesn't dissociate, but it's a concentrated weak acid because there are 10 moles per liter. So don't get those two terms confused. Hopefully this will help you to distinguish.